Hello, students of the world, and in Hargeisa and around Somaliland. This is your lecturer, Mustafa Abdi, Chancellor of the first international online YouTube University in Somaliland, Academia Hargeisa Universalis, based in Masaalaha, outskirts of the capital city of Somaliland, which is also the home of the school of visitors, whose first lecture at the school will be waived. There will be waves of students from all over the institution, and I will be in it. Waves are distances that transfer energy through matter or vacuum without transferring matter itself. Key properties including wavelength, frequency, amplitude, and speed governed by lambda. They are classified as longitudinal, or transverse, And for more information on the university and its lectures, follow me to my YouTube channel. Click the like button, subscribe, comment down how you on the made your progress on the AHU. So enjoy the lecture. In mathematics and physical science, a wave is a propagating dynamic disturbance, change from equilibrium of one or more quantities. Periodic waves oscillate repeatedly about the current value of some frequency. When the entire waveform moves in one direction, it's said to be a traveling wave. By contrast, opposed to superposed periodic waves traveling in opposite directions makes a standing wave. In a standing wave, the amplitude of vibration is nulls at some the wave smaller or even zero. There are two types of waves that are most commonly studied in classical physics: mechanical waves and electromagnetic waves. In mechanical wave, stress and strain fields oscillate about the mechanical equilibrium. A mechanical wave is a local deformation in some physical medium that propagates from particle to particle by creating local stresses that cause strain in magnetic particles too. For example, sound waves on variations of local pressure and particle motion that propagate through the medium. Other examples of mechanical waves are seismic waves, gravity waves, surface waves, and string vibrations. In an electromagnetic wave, such as light, coupling between electric and magnetic fields sustain propagation of waves involving these fields according to Maxwell's equations. Electromagnetic waves can travel through the vacuum and through the electric media at wavelengths where they are considered transparent. Electromagnetic waves are determined as frequencies by their frequencies, or may those have more specific designations including radio, infrared, terahertz waves, visible light, ultraviolet radiation, X-rays, and gamma rays. Other types of waves include gravitation waves, which are disturbance in space-time that propagate according to general relativity. Heat diffusion waves, plasma waves that combine mechanical deformations and electromagnetic fields, reaction diffusion waves. That is in the Belousov-Jabot-Budzinski reaction, and many more. Mechanical electromagnetic waves transfer energy, momentum, and information, but they do not transfer particles in the medium. In mathematics and electronics, waves are studied as signals. On the other hand, some waves have envelopes that do not move at all, such as standing waves, which are fundamental to music and hydraulic jumps. A physical wave field is often confined to the station of space to its domain. For example, seismic waves generated by earthquakes signaling on the interior and top of the planet, so they can be ignored outside it. Waves with an infinite domain, which extend over the whole space, are currently studied in mathematics and are very valid tools for understanding physical waves in infinite domains. A plane wave is an important mathematical idealization where distance is identical along any infinite plane to normal to a specific direction of travel. Mathematically, the simplest wave is a continuous line wave in which at any point the field experiences dynamic motion at one frequency. In linear media, common wave can be composed as the sum of many sinusoidal plane waves having different direction of propagation and/or different frequencies. A plane wave is classified as a wave if the field entry point is described by vertical and vertical propagation, also direction of energy transfer. Or the wave if those vectors are aligned with momentum direction. Mechanical waves include both translated and linear waves. On the other hand, electromagnetic waves are strictly transferred to all sample waves in fluids such as air, that direction of the static field relative to propagation direction is also referred to as wave, the wave direction, which is ordered attribute, which can be an important attribute.